So, good morning, everyone. This is the Mentor Hampeyo Kliman, and of course, I bring you a very special lesson on calculus where I'm going to be explaining very simplified concepts that you should be able to understand in order to make your calculus um, the easy way. And of course, this is HC Learning Academy, and if you would want to register for personal lessons, make sure that you inbox me on this WhatsApp number. It's a +26077664046 on WhatsApp, and I'll be able to respond to you. It's just 100 kwacha and you get registered at HC Learning Academy. And of course, if you are a student at Mulungushi University, 1st of May, my father in the Lord, then Apostle Alex BC Mutale, will be mounting Mulungushi University for an overnight, which will be taking place exactly 18 hours to the following day. So ensure that you are there, you get blessed, and then you see how the Lord is going to really change your life. Apostle Alex BC Mutale will be coming 1st of May exactly this year, of course, which happens to be next week from the day you will be listening to this video. Mulungushi University is the venue. Okay, so I want you to travel with me as I begin to solve calculus. We are going to start with a limit. How do you solve a question where they say they give you the limit as x is approaching 5, then this is going to be 2x to the power 2 minus 3x plus 4. So this is our first question. Well, the best way to solve this, or the simplest way, is simply to introduce your 5 where there is x, because this one is a direct question. Then from there, you're going to have 2, then 5 to the power 2 is 25, minus, this is going to be like 15, plus 4. This is going to be 50 minus 15, plus 4. Then from there, all you have to do is simply to be able to go directly. So if you go directly, you'll be able to get your answer, which is 50 minus 15, then plus 4, you'll be able to get something like 39. That is basically how you solve the first question, okay? Whenever a question is given to you that way. The second question is saying you have the limit as x is approaching -2, then you have x cubed, okay? X cubed, then you have plus 2x to the power 2, then plus 4, all over by, this is 5 minus 3x. HC students, this is just the same concept as the one I'm from applying. You need to look at your function and try to see if at all, if you put -2 where there is x, you should not be able to get a 0. It should give you some value. Whenever you get a 0, the function is telling you that do something about it so that you might be able to get another reasonable value. But for this one, because it's a polynomial function, it will be able to give us a direct answer. So you put your -2 there, plus -2 to the power 2 plus 4, then this is going to be 5 minus 3, then -2. So this is going to be like -8 plus, this is going to be 2, then +4 plus 4, then this is going to be 5 plus 6. Okay, so -8 plus 8 plus 4 is going to give us 4, all over by, this is going to give us positive 11. Okay, that is how you solve the second question. Well, let's try to go to the third question. We are going to solve particularly possibly 20 questions. You have the limit as x is approaching 7. Then they give you the square root of x plus 2 all over by x minus 7. Then they say this is plus 3. Okay. So like I mentioned, I will be skipping because this is going to be a long video. So it's going to be a long video. This is going to be a long video because you are traveling with me in calculus. Now, what you are supposed to do, whenever you are given such a question, you are supposed to find the conjugate of the root of x plus 2, then plus 3. So, let me conjugate this. This is going to be root of x plus 2. Then because it was a plus there, it will be a minus 3. The same thing, remember this multiplication. Then this is going to be x plus 2 minus 3. Then you are going to multiply the square root of x plus 2 multiplied by the square root of x plus 2. You are going to have x plus 2. Then root of x plus 2 multiplied by negative 3. You are going to have minus 3. Then x plus 2. Then this is going to be plus 3 multiplied by root of x plus 2. It will be 3 root of x plus 2. And then this is going to give you like a minus because 3 multiplied by 3, it's 9. Then all over by, you're going to have x minus 7. And then you're going to have the root of x plus 2 minus 3. Notice that this and that are going to cancel. So what you're going to remain with is like x plus 2 minus 9 all over by x minus 7, then x plus 2 minus 3. Like that. Now notice they are saying that we've got, this is x plus 2 minus 9. So this is going to give us like x minus 7. Then this is going to be x minus 7. Then you are going to have the square root of x plus 2, then minus 3. Notice that this is going to give you a 1 when it cancels with that. So you are going to have like a 1 over square root of x plus 2 minus 3. Now notice that the root is approaching 7. Okay. So when x is approaching 7, we're taking the limit as x approaching 7 of 1 over, then you have the square root of x plus 2 minus 3. So I'm going to replace 7 here plus 2 minus 3. And this is going to give me 1 over, this is going to give me the square root of 9 minus 3. Okay, so 1 over the square root of 9, this is going to be like 1 over 3 minus 3, it's giving us 1 over 0. Whenever you find something like this, even after manipulating a function, what it is basically telling you is the limit does not exist. Okay, the limit does not exist. Okay, we go to another question, just a minute. Basically, that is how you'll be able to determine whether a limit exists or a limit does not exist. So for this particular question, the limit does not exist. Okay, we proceed. Let me just grab the board. We go to question 4. These questions are very simple. All you have to do is travel with us. We go to another question, which is going to be our question 4. Question 4 is simply saying the limit as x is approaching positive infinity of x to the power 2 minus 1 all over by x to the power 2 plus 1. Now notice that the limit this time around is approaching a very big number, which are calling as positive infinity. So the easiest concept that I taught HC students is all you have to do is to recognize the denominator. Recognize the highest power of the denominator or the numerator. Okay? So in this case, the highest power is simply x to the power 2. And that implies that everywhere I shall be multiplying by this factor x to the power 2. So I'm going to take my x to the power 2 multiplied by, okay, let me do this. So this is going to be multiplied by 1 over x to the power 2 minus 1 over 1 multiplied by 1 over x to the power 2. And everything by, even in the denominator I will do the same, to be x to the power 2 multiplied by 1 over x to the power 2 plus 1 multiplied by 1 over x to the power 2. Now notice that if you have 1 over x to the power 2, then you introduce an infinite number. By imagination, maybe let's say I'm thinking 10,000. Okay, 10,000. Okay, let me imagine of a number. 10,000 to the power 2, if I divide by 1, the number will be 0.00000 something, or let me just say my number is going to be close to 0. So this one is same as 0, right? So if I cancel this and this, I'm getting a 1 minus this part here. It's going to give me 1 over x to the power 2, and that is giving me a number close to 0. The same thing here, I'll cancel and I'll cancel here, I'll remain with 1. The same thing here, 1 over x to the power 2 will give me a number which is close to 0. So this is going to be 1 over 1, and then my answer is going to be 1. That is how you solve limits at infinity. Let's try to get another one, which we can call 5. Question 5. Suppose you have the limit as x is approaching positive infinity. Then you have 4 x to the power 2 minus x minus 2. Then they say all over by 5x to the power 2 plus 4x plus 1. Let's see, look at this. You have been given a big number, then they ask you to find the limit of this particular function. You use the same concept, recognize the highest power both in the denominator and the numerator. You choose one highest power. So when I check in my numerator, I check in my denominator, the highest power is simply x to the power 2. Okay? Because that is what we have. That is the highest degree. Then you will be multiplying everything by a factor 1 over x to the power 2. Now, notice what is going to happen. If you do that, then that implies you're going to have 4 x to the power 2 all over by x to the power 2, right? You're multiplying everything. Minus x over x to the power 2 minus 2 over x to the power 2, then all over by 5x to the power 2 over x to the power 2 plus 4x over x to the power 2 plus 1 over x to the power 2. Now I want you to notice something. This and that will cancel. You're going to remain with a 4. Then here, that is going to cancel. It's going to be 1. Here you're going to remain with x. I want you to imagine infinity as 1 trillion. 1 divided by 1 trillion, it will be a number such that 0.000 something, but the number is going to be close to some 0. So this part is giving you 0. Even here, 2 over x to the power 2, 1 trillion to the power 2 is an infinity number you can't even count. Henceforth, this will also give you a number close to 0. This side and this side you can cancel. This will give you 4 over x because that and that will cancel. But 4 divided by 1 trillion, it will be a number close to some 0 again. Even here, it will be a number close to some 0, some 0. The only eligible number you have is a 4 over 5. And that is the limit that you are finding. Okay, that is just how you solve those particular questions. Let's see, we go to another question. We see how best we can answer. Okay, I want you to look at this. You have the limit as t is approaching negative infinity. Then you have t to the power 2 plus 2. Then you have t to the power 3 plus t2 minus 2. Now you check the highest power that you have. When you check the highest power that you have is simply your t to the power 3. Okay, let's try to check if there is anything that we can do to manipulate this. It's very important. Okay, so what is your product? Your product is negative 2. Your sum is 1. So your factors are going to be 2 and negative 1. So this is going to be like t3 minus t plus 2t minus 2. So what is common? T is common, then t to the power 2 minus 1. Okay, then this is going to be 2 is common, then t minus 1. So we are going to have t minus 1, okay, like that, and then we are going to have t plus 2, okay, t plus 2. So if you notice what is happening, okay, if you notice what is happening, you discover that this is the same as t negative infinity of t2 plus 2 all over by t to the power 2 minus 1, then t plus 2, like that. But even if you maintain that your power is x to the power 2, because that is the greatest power, sorry, t to the power 2, that is our greatest power. T to the power 2 is our greatest power. That implies we're going to have t to the power 2 like that. But even if we multiply by, we say this is going to be t to the power 2 over t to the power 2, t to the power 2. I want you to look at this. This particular function is not going anywhere, and I'll show you. Okay? And you say t to the power 2. Okay, t to the power 2. Whatever you are having there, you are dividing by t to the power 2. Okay? Then you say minus 1 over t to the power 2. Then t over t to the power 2 plus 2 over t to the power 2. I want you to notice something. You'll notice that whatever you're going to have in here is going to be a 0, right? And because what you can have here can be a significant value, because this and this will give you a 1. 1 minus 0 will be a 1. But still, because you have a 0 multiplying by a 1, you will still have something like this, because this 0, so you still have something like a 1 over 0, because this 0 is multiplying everything here, which is giving an undefined value. Let's see, look at this. Even from the beginning, you are able to see that the greatest power was in the denominator. Okay, the greatest power is in the denominator. That implies that on top here, you are going to have a 0. Down here, you are going to have like a 1. Okay? So basically, for this particular function, your limit does not exist. Okay? Your limit does not exist. Okay? This should be question 6. Okay, let's try to do question 7. We see how best we can answer 7. How about if you have been given a radical where they say limit as x is approaching positive infinity, then they say x plus 2 all over by square root of, this is going to be 9x to the power 2 plus 1. So I want you to notice this. How do you solve this particular question? Well, because all you have to do is simply to repeat first of what is on top. So you're going to have your x plus 2 all over by, then because 9 and x to the power 2 are multiplying, this is going to be the same as square root of 9 multiplied by square root of x, then all over by, okay, 1, like that. Okay, all over by 1 like that. Then of course you are going to understand that, okay, so this is just like let me just say this is 1 over 9, okay, like that. Okay, let me put it that way, so that when you multiply, you are still able to get the same value. So notice what is going to happen. So what is going to happen is you are going to have x plus 2 over, this is going to be like a 3 over, then this is going to be like square root of x, okay, square root of x there, it's going to give you that, and that will cancel. You're going to have your x, and then plus root of 1 over 9. Okay? Before you even go any further, you are able to trace your value. So this value and this value are constants. So before you even go any further, you can remove them out. Okay? So you're going to have, why am I removing them? Because I know that my highest value is x. So if I divide by x, it will be 0. If I divide by this by x, it will be close to a 0. So, because my highest power is x, so I'm going to remain with x over 3x. And that is what is going to be significant. Okay? So my highest power is x, so this is just the same as this, and that will cancel. So I'm going to have 1 over 3. Okay? That is basically how you solve this particular question. Okay? The easiest way. So you just have to look at the constants. Of course, constants are going to give you a value close to some 0, and then you'll be able to get something sensible. Okay? That is very simple. Let's try question 8. Question 8 is saying limit as x is approaching negative infinity, then you have 3 over, then you are going to have 4, then 1 plus square root of 1. Okay, let me say square root of 1 minus 3 over 16x. Now, I want you to notice something then, close bracket. I want you to notice something. On top, you do not have x. You only have a constant. So for this particular question, just go directly. So you're going to have x all over by 4, open bracket, 1 plus, then this is going to be the root of 1 minus 3 over 16, negative infinity. Now notice that 16 multiplied by negative infinity is going to be a very huge number, okay, which will be close to 0, okay. Same concept like we did there. So you're going to have a 3, and then you're going to have a 4, open bracket, then 1 plus, this will become a 0, because this will be a number close to some 0. So you're going to have 1 minus 0. Then 1 minus 0 is 1, square root of 1 is 1. Then 1 plus 1, okay, let me do this. Notice that you're going to have a 1 here. Then 1 minus 0 is 1. The square root of 1 is 1. 1 plus 1. What are you getting? You're getting a 3 over 4. Then 2 inside. This is going to give you 3 over 8. Okay? And basically that is how you get your final answer. Okay? So that is question 8. Okay, let's see. Let's now proceed. We go to question 9. So the beauty about limits is you are able to see your answer even before you are able to reach your final destination. You're able to see your answer before you reach your final destination. Okay, that was question 8. Let's do question 9. Question 9, they're simply saying we find the limit as x is approaching negative infinity. Beautiful. We have been given a radical once again. This is 9x to the power 6 minus x all over by x cubed, then plus 6. How do you solve such a question? Well, this is going to be very, very simple. So the first thing we are going to do, we are going to factorize, because this multiplication, so we can factorize x to the power 6 multiplied by the way, this is going to be like square root of x to the power 6. Then the same thing that we did there, this is going to be like 9 minus x, right? 9 minus x. First of all, we'll work out whatever is on top. Then this is going to be like x cubed plus 6. From there, you're going to have, look at this, square root of x to the power 6 is the same as x to the power 6 1 over 2, which is the same as x to the power 6 1 over 2. So this gives you x to the power 3. So this is going to give you x to the power 3, right? Then you're going to open the bracket. Then this is going to be 9 minus, because I really want to maintain the x inside when I multiply, so it's going to be 1 over x to the power 2. So that when I multiply x by this one there, it will be x to the power 3. Then divide by x to the power 2 to give me x. Okay? Then from there, this is going to be x to the power 3 plus 6. If you check the highest power now, the highest power is simply x to the power 3. So you can now take the limit as x is approaching negative infinity. So you discover that the highest power is x to the power 3. So already this part will become a 0. This part will become a 0 because 1 over x to the power 2, if you put infinity there, it will become a 0. Then, because it's negative infinity, you expect that this value is also going to be negative. So divided by negative 3 to the power 2. That's where the function is going. Even this side, negative 3 to the power 2. So you're going to have negative 1. Okay. Sorry. You're dividing by negative 3, negative x to the power 2 because it's a negative here. Okay? Negative infinity. So you're going to have negative 1 because you're dividing you're dividing x to the power 3 over x to the power 3. You're going to get negative 1. Then square root of 9 minus 0. Inside this is a 0 part. All over by, of course, sorry, this is supposed to be power 3. So that is going to give you like negative 1. Okay. And then this is going to give you something like plus 0. Okay. So at the end of it all, sorry, supposed to be negative. Okay. At the end of it all, you're going to get square root of 9 over negative 1. Then you get your negative 3 as your answer. So when you check, whenever you have been given a question and the question has a limit which is traveling towards negative something, negative infinity, make sure you know that your limit likely might be a negative limit. Okay? Might be a negative limit. But make sure that the procedure that you follow is the one that I have given. Okay, quite very simple. We now wrap the board. We do something different, which happens to be our question 10. Okay, let me just take some water. Oh, welcome back, HC. Let's continue. Question 10. We have been given the function of f of x equal to 3x to the power 2. They are saying we find the derivative. To find the derivative, we are using f prime equal to f x plus h. We are using first principle to find dy dx. So it will be a minus f of x all over by h. So the first thing that you need to do, you need to calculate this part here. So this is going to be your f x plus h is going to equal to, so you're going to say 3. Remember, when I'm doing functions, while there is x, you're going to put x plus h, then to the power 2. So this is going to be 3. Open the bracket. Then you're going to have x plus h, like that. Now notice that when you multiply the 2, x multiplied by x is x to the power 2. X multiplied by h, it is hx. H multiplied by x is plus hx and plus h. 3 multiplied by x is 3x to the power 2 plus, of course, this is going to be 2hx, so 6hx plus, so this is supposed to be power 2 plus 3h to the power 2. So this is fx plus h. We have found it. Now we can find our fx, which happens to just be 3 to the power 2. We can replace in. So while there is this guy, I'm going to replace with this. minus 3x to the power 2. Then this is going to equal to, notice that this is a minus, so it will cancel with this. Then you're going to remain with 6hx plus 3h to the power 2 over h. What is common there? H is common. Then 6x plus 3h all over by h. You cancel that, you cancel that. You're going to remain with 6x plus 3h. When you reach here, you now take the limit as h is approaching some 0, and then if you put 0 here, you find 0, so you're going to have the final answer as 6x. That is how you find the derivative of that particular function. Okay, let's try to do another one. Sorry. Okay, that is going to be question 11. How about if you have been given f of x is equal to 3x plus 5, then you're using the same principle. You're going to have your fx plus h minus fx all over by h. The same concept. Let's work out this part. So your fxh your fx plus h, you have 3x plus 5. That implies that fx plus h, where there is x, you replace with this, and then you're going to have 3x plus 3h plus 5. That is what you are going to have as your fx plus h. Now we can find our f of x. Our f of x was simply 3x plus 5. So now we can replace in, while there is this part, I can replace with 3x plus 3h plus 5 minus, then I open the bracket, 3x plus 5, then h. Then this is going to give me 3x plus 3h plus 5 minus 3x minus 5, then h. This and that will cancel, that and that will cancel, then you are going to remain with 3h over h. This and that will cancel, you are going to remain with a 3. That is how you solve this particular function using first principle. Okay, let's try to go extra. So that was question 11. Let's now try to do question 12. How about if you have been given f of x is equal to x over x minus 1? Okay, how do you go about solving such a question? How do you solve such a question? The same concept. We are going to use our first principle. F prime of some x is equal to fx plus h minus fx over h. So now we are going to find our fx plus h is equal to, we have the equation there, which is x over x minus 1, then x plus h. Notice what I'm going to do. Where there is x, I'm going to replace with x plus h. Even in the numerator, x plus h. Same concept. Okay, then of course our f of x was equal to x over x minus 1. Now let me replace in. While there is this guy here, I can replace with this. So it's going to be x plus h all over by x plus h, then minus 1, then minus the function that we have there, which is x, then x minus 1. Everything will be all over h. What is the common denominator? Work out whatever is on top. Our common denominator is simply x plus h minus 1, then x minus 1. X plus h minus 1 into this, we are going to have x plus h, then x minus 1. Then this is going to be a minus. This into that, we are going to have our x, and then we are going to have x plus h minus 1. When we reach there, we can now expand everything. X multiplied by x, it is x to the power 2. X multiplied by negative 1 is minus x. H multiplied by x is hx. H multiplied by negative 1, it is h. Then this is going to be a minus. We multiply whatever is inside. X multiplied by x, x to the power 2. X multiplied by h, it's plus hx. X multiplied by negative 1, it's minus x. Okay, everything divided by h. Okay, from there, this is going to be x to the power 2 minus x plus hx minus h minus x to the power 2 minus hx plus x all over by h. Notice that this and that can go. Okay, this and that can go. By the way, we should not forget we are divided by this. We are dividing by that. Okay. Okay, let me just write it this way smartly so that we don't get lost. Possibly even before we cancel that. So notice here I just forgot, but I'm supposed to write divide by this. Then everything all over by h, right? Notice that this and that will cancel. Then this negative x and that positive x will cancel. What else can cancel? This plus h and that can cancel. Going to remain with the negative h. So negative h over, then we are going to have x plus h minus 1, then x minus 1. Then because we are dividing by h, if you multiply by h, you discover that the h will come here. You know, when you're dealing with the division, okay, because this is h over 1, if you divide, you flip them, you'll find something like that. So this h and this will multiply. You're going to have negative 1 all over by x plus h minus 1, then x minus 1. Okay, when you reach here, you take the limit as to h is approaching some 0. You discover that you're going to have negative 1 over, if you put 0 here, you're going to have x minus 1, then x minus 1. And then your final answer is going to be something like negative 1 over x minus 1 to the power 2. Okay, that is how you solve this particular question. Okay, let's try to wrap the board. We solved something interesting. If you're lagging behind in mathematics, you feel left behind, why won't you join HC Learning Academy and enjoy our lessons every day. So immediately you register, you get to access all the lessons that we taught, and everything is going to be simplified for you. Let's travel into another question. Okay, so that was question 12. This one is going to be question 13. Question 13, we are using first principle. They give you the function of f of x is equal to, then there's a root of x to the power 2 plus 1. Okay, square root of x to the power 2 plus 1. Use the same concept. We're using the first principle. But first of all, we can work out this. So this is going to be the square root of, while there is x, we replace with x plus h to the power 2 plus 1. Okay, and then our f of x is going to equal to a root of x to the power 2 plus 1. Using first principle, f prime of some x is equal to, we are going to have the square root of x plus h to the power 2. Then this is going to be like plus 1 minus x to the power 2 plus 1. Everything is going to be over h. Now when we reach here, we can rationalize. We find the conjugate. So to find the conjugate, you will multiply by the same thing. But this time around, you put an addition sign. Even this side, you do the same thing. You also put the same thing. Okay, then you are going to multiply. Square root of this multiplied by that, of course, you are going to have x plus h to the power 2 plus 1. Then this multiplied by that, it's going to be plus root of x plus h power 2 plus 1. Then square root of x to the power 2 plus 1. Then minus this, minus square root of x to the power 2 plus 1 multiplied by x to the power, multiplied by square root of x plus h to the power 2 plus 1. Then this is going to be minus x to the power 2 plus 1, and then root of x plus h plus 1. And then you say plus. Sorry, by the way, it's going to be a minus. Quite long, but very easy. Then you multiply square root of x to the power 2 plus 1 multiplied by square root of x to the power 2 minus, sorry, plus 1. It's going to be a minus because this and this is multiplying. Yes. So now you're going to have x to the power 2 plus 1 all over by h, then square root of x plus h plus 1, then square root of x to the power 2 plus 1. Notice that this is a 0. The entire of this is going to be 0. So you are going to remain with x plus h to the power 2 plus 1 minus x to the power 2 minus 1. Okay, like that. Then this is going to be all over by h to the square root of x plus h plus 1 plus square root of x to the power 2 plus 1. Okay, so I can wrap the top part. Okay, so when we reach there, we can expand this. But I know that when I expand x plus h to the power 2, I was basically just get x to the power 2 plus 2hx plus h to the power 2. Okay, that we know. So this is just the same as, let's see, let me just wrap the top part. Quite very interesting question and very long. Okay, so I'm going to have x. Okay, let me just use another color as a continuation. I'm going to have x to the power 2 plus 2hx plus h to the power 2, like that. Then this is adding this, say plus 1 minus x to the power 2 minus 1, then all over by h, open brackets, square root of x plus h plus 1. Okay, so let's see what can cancel. Do we have anything? So that and that can cancel. This negative 1 and that positive 1 can cancel. Then we are going to remain with 2h plus h to the power 2. Okay. Now notice that let me just write that. Notice that when you reach here, you can factorize. So what's common there? H is common. Then you're going to remain the 2 here plus h. Then you're going to have your h there, then open brackets, square root of x plus h plus 1 plus square root of x to the power 2 plus 1. Okay, so this and that can go. Okay, so when it goes, you're going to remain with 2 plus h. Now notice what is going to happen here. If you introduce, okay, let me just write it so that we see how clear it will be. You remain with x plus h to the power 2, then plus 1, plus square root of x to the power 2 plus 1. So if we introduce the limb as h is approaching some 0, let's see what will happen. Okay, so this is going to be like, we put a 0 here. Okay, we also put a 0 here. Okay, then we put a 0. Okay, so what we are going to remain with is going to be 2 over, then square root of, this is going to be like x plus 1, so x to the power 2 plus 1. Okay, then this is going to be plus x to the power 2 plus 1. Okay, then altogether we're going to have 2 over 2 square root of x to the power 2 plus 1. Okay, that is what you're going to have at the end. Quite long, but very, very simple. Okay, I wanted to be very careful enough so that I don't make a mistake. But basically, that is going to be your final answer. Let's see, let me take a break. I just drink some water. Of course, 1st of May, we'll be having our overnight with the man of God, Apostle Alex B.C. Mutale from Upper Room Nation, Upper Room Proper Embassy, Kabwe. Of course, to be taking place 1st of May at Mulungushi University. The mentor himself, Humbert Kliman, will be coming. Okay. So this is a long session. We're having. Let me just take a breath. It's a long session, very, very long. Question 14. Okay, let's do question 14. Question 14 is saying we find dy dx of the following. A, they are saying x to the power 2. This is question 14. Then 3x plus x, then all over to the power 4. Okay, so whenever you find two expressions or two functions being composite, what you are using is called the chain rule. And chain rule, the concept is very simple. You have a person who is standing outside the vehicle. You have the vehicle itself. Then you have a person who is seated in the vehicle. With the chain rule, you find dy dx of the person outside the vehicle. Then you maintain every other thing. Then you say plus. Then you find dy dx of the vehicle itself. You maintain every other thing. Then you say multiplied by the person, dy dx of the person inside the vehicle. What do I mean? So, the first thing you do, whenever you have something in your brackets, or, let me first of all make reference. This guy here that you see is the person who is outside the vehicle. These brackets with the power 4, that is the vehicle itself. Then this function expression inside, that is the person inside the vehicle. And we'll be following those steps. Okay, HC students understand chain rule easily. Make your vehicle or make the person inside the vehicle equal to u. Use the u substitution, so you let u equal to x to the power 3 plus x. And that implies that we're going to have x to the power 2, open bracket of u. Notice that it is the person inside the vehicle that I have replaced with u, not the vehicle itself. Then what did we say? We find dy dx of the person outside the vehicle. So dy dx of this is simply 2x. Then every other thing maintains, plus. We now maintain every other thing. But this time around, we multiply, we find dy dx of the vehicle. So dy dx of the vehicle, we're talking about the brackets. So this is going to be 4. Then every other thing maintain, then to the power 3. Because you're supposed to be reducing by 1. Okay? Then remember what I said. You now maintain every other thing or let me just say you now multiply by dy dx of the person who is inside the vehicle. So what's inside the vehicle? So we now find dy dx of whatever is inside the vehicle. Dy dx of u. Now let's do the replacement. So this is going to be 2x. While there is u, I'll bring back x to the power 3 plus x to the power 4 plus, this is going to be like 4 x to the power 2. While there is u, I'll replace the 3x, x to the power 3 plus x, and then to the power 3. Then all over will multiply by dy dx of u, the person inside the vehicle. So this is just the same as 3x, then 3 minus 1, which is a 2, plus, this is x, so it will be a 1. So, and that is our final answer. Okay, that is our final answer for this particular question. We now go to question 15. Question 15 is simply saying we find dy dx of y is equal to cosine to the power 2 x cubed minus 4. How exactly do we go about this? Okay, remember we have two expressions, one which is a trig, the other one which is an algorithm expression, just a normal algorithm expression. The same thing. What is inside the vehicle is x to the power 3 minus 4. So use u substitution, you say let u equal to x cubed minus 4. Okay, then this is going to be u is equal to cosine to the power 2, then u, which is just the same as cosine u to the power 2. Okay, now we do not have anything outside the vehicle. What we have is the vehicle itself and something inside the vehicle. So we skip the stage 1 of dy dx of outside of the person outside the vehicle. We now go to the vehicle itself. So dy dx of the vehicle is going to give us, the 2 is going to come to this side. Okay, 2 will come this side. Then of course we are going to have our cosine u like that. Then remember, whenever you are now doing dy dx of what is inside, you are multiplying. So dy dx of what is inside is minus sine, okay, minus sine u, then multiplied by now dy dx of whatever is inside, cosine, which is the u, now the inside u. Okay, so now dy dx of u. So now let's do the replacement. So it's going to be 2 cosine, what is u? U is 3x to the power 3 minus 4. Then multiplied by sine, what is u? X to the cube minus 4. Then multiplied by what is u? We now do dy dx of the person who is inside the vehicle now. Okay, make sure you understand how I'm using the chain rule. Okay, so this is going to be like 3x to the power 2. Then because this is a constant, it will be a 0. Okay, so now we have everything. So these 3 will be multiplying with these 2. So we are going to have, so this 3x, so we're going to have 6 . Okay, we're going to have 6 x to the power 2 cosine x to the 3 minus 4, then sine x to the 3 minus 4. Why have I taken the negative? I've put it in front. Okay, that's how we solve general questions using dy dx. Okay, let's see if at all we have another interesting question Well, we can use our chain rule. Okay, let's do question 16. So we have y is equal to root of 1 minus x to the 3 all over by x to the power 2. How do you find dy dx of this? Whenever you have been given a radical, to find dy dx or the derivative of this, you don't have to use the first principle. What you have to use is simply trigonometry. Okay? You are going to use trigonometry, then you are going to simplify your calculus. How do you go about it? HC students, listen to me. You introduce your natural log of y. You also introduce the natural log of your square root of 1 minus x to the power 3. Then you introduce your dy over dx. Now, dy dx of ln of something will give you dy over dx multiplied by 1 over y. Please make sure you take that concept. Dy dx of ln of something, it's dy dx over, so dy dx multiplied by 1 over ln of y. Now, remember when I was teaching you trigonometry, when I was teaching you logarithms, by the way, use logarithm to be able to find this. When I was teaching you logs, you remember that ln of root of 1 minus x to the power 3 over x to the power 2 is the same as ln of root of 1 minus x to the power 3, then ln of x to the power 3, like that. That's a very important rule in logarithms. So this is the same as the natural log of square root of 1 minus x to the 3 minus then ln of x to the power 2. Get the concept, let's see. When you reach there, you have your dy over dx. Then this is just the same as, look, this is the square root, right? So this is the same as 1 minus x to the power 3. Then this is just the same as 1 over 2. Okay, 1 over 2 to the power 1 over 2. That's just the same thing. Okay, so this 1 over 2 can actually come to the front because we are dealing with logarithms there. So dy over dx, 1 over y is equal to 1 over 2, the natural log, and then we are going to have 1 minus x to the power 3 minus ln of x to the power 2. Now when you reach here, what is ln of this particular expression? Whenever you have got the natural log of x to the power 2 or x to the power 4, natural log of x to the power 4, it is simply dy dx of whatever is the x to the power 4 over the original x to the power 4. So what is dy dx of x to the power 4? It is 4x to the power 3 over the original. Okay, that is ln of x to the power 4. Take note. So even here we do the same thing. What is ln of 1 minus x to the power 3? So you do dy dx of whatever is inside. So this will be 1 over 2. What is dy dx of whatever is inside? It will be minus 3x to the power 2 all over by the original, which is 1 minus x to the power 3. Okay, minus, what is dy dx of this? It will be 2x over x to the power 2. From there, you are going to have dy over dx 1 minus y is equal to, okay, so you now do the top, you are going to get minus 3x to the power 2 over 1 minus x cubed. Okay, by the way, this is supposed to be multiplying because the 2 is multiplying whatever is down there. Then this is going to be minus 2x over x to the power 2. Now let's try to do the final answer. So how do we cancel out? We want to just remain dy dx this side. So we say multiplied by y over 1, even this side. Even this side, you are multiplying by y over 1. So this and that will cancel. You're going to have y is equal to, you're going to have dy over dx equal to, okay, so you're going to have minus 3x to the power 2 all over by 2, 1 minus x to the power 3 minus 2x over x to the power 2. Then because you've got the y there, so you bring back the function, square root of 1 minus x to the 3 all over by x to the power 2. And that gives you the final answer. That's how you find the derivative of such a function. It's actually very, very simple. Okay, so this was question 16. Let's do some more questions. Okay, let me just have some more boards what to write from. Okay, so that was question 16. Now we do question 17. I'll be very, very, very fast. You've got your y is equal to square root of 2 plus 3x to the power 2 all over by x to the power 3. Same concept, but this time around I'll be very quick. So of course I'll introduce the natural log of y, and even this side the natural log of square root of 2 plus 3x to the power 2 all over by x to the power 2. Then of course I'll do dy dx of this guy, okay, of ln of y. Then this side you just maintain. Of course, dy dx of ln of y is going to give you dy dx 1 over y is equal to, then of course this is going to be ln of square root of 2 plus 3x to the power 2 minus ln of x to the power 3. Then here this is going to be dy over dx 1 over y. This is going to be like ln. Then this is going to be like 2 plus 3x to the power 2 1 over 2 ln of x to the cube. Dy over dx 1 over y is equal to, this will go this side, so it will be 1 over 2. Then we have the ln of 2 plus 3x to the 2 minus ln of x to the 3. From there, we are going to have dy over dx of 1 over y. Okay, so we now do our thing. So this is going to be like 1 over 2. What is ln of this? It is what is inside dy dx. What is dy dx of whatever function is inside? It's going to be 6x, right? 6x over the original, which is simply 2 plus 3x to the 2 minus, okay, let me just close, minus ln of x to the 3, that is dy dx of whatever is inside, which is 3x to the 2 over x to the 3. From there, we are going to have our dy over dx of 1 over y, which is going to equal to 6x over 2, then 2 plus 3x to the 2, minus 3x to the 2 over x to the 3. So this is something that will not be taught in class, and that's the reason why we encourage that you register at our school for personal lessons. And of course, you multiply by y over 1, even this side by y over 1, so that this y and that can cancel. You remain with your dy over dx is equal to, so you now write your final answer, which is 6x over 2, then 2 plus 3x to the 2, minus 3x to the 2 over x to the 3. Then you bring back your equation, which is the root of 2 plus 3x to the 2 over x to the 3. And that is exactly how you are able to write your question. So if you see at the end of it all, I now have something that is really making sense. That is basically how you are able to find dy dx of any radical function that you have been given. Okay, question 18. Question 18, they are saying y is equal to ln of 1 minus x to the power 2 over 1 plus x to the power 2. Well, it's very simple. dy over dx is equal to, okay, so this is going to be okay, let me just use simplicity function. Okay, so this is going to be like ln is going to be like ln of 1 minus x to the 2 minus the ln of 1 plus x to the 2. Then this is going to be, what is ln of this? It is dy dx of what is inside, which is minus 2x over the original equation, which is 1 minus x to the 2. What is ln of this? It is dy dx of whatever is inside, which is 2x over whatever is going to be inside the function, which is 1 plus x to the 2. Okay, that is how you solve this particular function. Okay, we now go to question 19. They say y is equal to ln of e to the x to the power 2, and then all over by x to the power 2. So for this one, this is just the same as dy over dx is equal to, you're going to have ln of e to the x to the 2 minus ln of x to the power 2. Now how do you find dy dx of this? Dy dx of e to the x to the 2 you need to find dy dx of this. So dy dx of x to the power 2 is simply 2x. Then the same 2x you now multiply by this, right? Okay, so dy dx of that is dy dx of e, then power x to the power 2 is the same as the same dy dx. Okay, let me give you a formula. Whenever you're finding dy dx of, let's say, e to the u, the answer is the product of dy dx of u, okay, then you multiply it by e to the u original. So in this case, what was our dy dx of u? Dy dx of u was 2x, so we are multiplying the 2x by e to the x to the 2, and then we're going to get 2x e to the x to the 2. Okay, that is going to be our dy dx inside. So you can say dy over dx is equal to, so this is going to be 2x e to the x to the 2 all over by the original, which is x to the x to the 2, minus, and this part dy dx is going to equal to minus 2x over the original, which is x to the 2. And that is basically how you are able to solve such a question. Okay, let's see, let me just get some water. I take some water. This is how you solve these particular questions. Okay, let me just give you some task. I want you to find, which is going to be 20. I want you to find dy dx of y is equal to 3x plus 8x to the 4 over 2 minus x to the 3. Then an extra, I want you to use first principle to find the derivative of cosine 3x. Okay, if you found this video helpful and interesting, don't forget to subscribe to my YouTube channel, and also don't forget to register for personal tuitions. Okay, don't forget to register for personal tuitions. And if you want to register for personal lessons, you feel like you want to be part of Etsy family, inbox me on WhatsApp on +26 0777 66 40 46. Price says it's just 100 kwacha each course monthly. Make sure you inbox and you be part of our Etsy family. If you found this video helpful and interesting, once again, Etsy family, don't forget to subscribe, hit the like button, don't forget to share to others. The mentor Hampir Kliman, thank you so much.